Hi, Jack is back with another interesting kinematics problem. An elevator starts from rest and accelerates for 20 seconds to reach its top speed. It then immediately starts decelerating and comes to a stop in 22 seconds. If the distance traveled is 441 meters, estimate the top speed, acceleration, and deceleration of this elevator. At first glance, this problem might seem a little tricky. We're not told exactly how the elevator is moving, and in particular, we're not told if the acceleration is constant, which means that we cannot directly apply the four kinematics equations for motion with constant acceleration. But notice here that we are only asked to find an estimate. So I hope you agree that a reasonable assumption to make is that the acceleration and deceleration are constant. Then we have two phases where we can apply the kinematics equations. If this is enough to get you started, I encourage you to pause the video now and try to solve the problem yourself. Then come back and see how I solved it. So I'm going to start my solution by drawing the velocity time graph. And hopefully, this will help make the solution a little easier to visualize and understand. We're going to start with our elevator at rest, so at zero velocity, and we're going to climb in a straight line because we assumed constant acceleration up to some top speed, and let's label it v top. Then the elevator is going to decelerate also at a constant rate until we get to zero velocity again. So this first phase is going to take 20 seconds, and the second phase is going to take 22 seconds. And the main idea we need to solve this problem is that the distance traveled is the area under the velocity time graph. Now, this is a very important concept for kinematics, so if it's unfamiliar to you, click on the link in the top right corner for my video that explains this in depth. The idea, of course, comes from integral calculus. But don't worry, we don't actually need to know how to do calculus for this problem, since we already know how to find the area of a triangle. And as you can see, the area under this velocity time graph is the area of a triangle. Here, the base of this triangle is 20 plus 22 seconds, which is 42 seconds. And the height is our v top. So the area of this triangle is a half times base times height. And let's just simplify that to 21 seconds times v top. And using our main idea that the distance traveled is the area under the velocity time graph, we're also given that the distance traveled is 441 meters. So we know that this area is equal to 441 meters. So now we can easily solve for v top by dividing both sides by 21 seconds. And we get a top speed of 21 meters per second. Alright, so that's the first answer down. And next, we just have to find the acceleration, which would be the slope of this line, and the deceleration, which would be the slope of this line. And of course, the slope of a straight line is fairly easy to find. Let's call the acceleration a1, and that's going to be equal to vf minus vi over t. Vf is going to be the top speed we just found of 21 meters per second, and we started from rest. So that's a 0. And then the time, well, that was 20 seconds. So that gets us an acceleration of 1.05 meters per second squared. The deceleration, let's call that A2, is equal to Vf minus Vi over t, so same formula. And that's equal to, well, we come to a stop, so Vf is 0, and minus our top speed of 21 meters per second, this time divided by 22 seconds. And that's going to give us roughly minus 0.95 meters per second squared. Compare this solution to how you might solve the problem using the kinematics equations. Did drawing the velocity time graph help make the solution easier for you? Now, if you're thinking, isn't 21 meters a second a little fast for an elevator? Well, you'd be right. This is a very fast elevator. In fact, the values I chose for this problem are based on the world's fastest elevator installed by Hitachi Building Systems in Guangzhou, China. If you want to learn more about the world's fastest elevator, check out some of the links in the description below. To test your understanding, what if we did not assume the acceleration of the elevator is constant? What limits could we put on the top speed of the elevator if the acceleration could be infinite? What would the velocity time graph look like in those limiting cases? Leave your answers in the comments below. If you like this video, don't forget to leave a thumbs up and subscribe for more problem-solving videos like this one. See you soon.